All right, gentlemen. Hope you enjoyed your nice, easy return yesterday with a nice study hall to start our semester off after Christmas break. Unfortunately, COVID has caught up with me, and I tested positive yesterday morning. So I will be out this whole week and potentially the beginning of next week as well. So what that means is we will still have class, you'll still have assignments, but they will primarily be videos like this. So we'll kind of walk through the lesson for the day, and you guys will have your normal homework assignments. It's going to make going over homework a little more difficult, so maybe one day towards the end of this week, maybe Thursday or Friday, I'll email you guys and we'll set up a Zoom to kind of go over anything that you guys have questions on. But otherwise, that's going to kind of be how we go throughout this semester, at least to start here. So if we look at today's lesson, we're going to jump in right where we left off before we had our exams, which, by the way, exam scores, they're not posted yet, but for the most part, you guys did a really good job on those. So kind of kudos to you guys. It's really nice grading those as a teacher to see good results and know that you guys really put in a good effort. So thank you for that. But back to 6.4, we're going to talk about proving triangles similar by AA, or angle-angle. If you remember back to first semester before Christmas break, we started talking about similarity in triangles. So similarity is different than congruency. Remember, similarity is the angles, or your corresponding angles in your triangles are all congruent and your sides are proportional. So if we look at our angle-angle here, this first one, it says if two angles in one triangle are congruent, the two angles of another triangle, then the two triangles are similar. So we have two triangles here. We have triangle JKL and triangle XYZ. These triangles are similar as stated here. And our corresponding angles are congruent. So you can see angle J is corresponding to angle X. Those are congruent. Angle K is corresponding to angle Y. Those are congruent. And that would mean that angle L corresponds to angle Z, and those are also congruent. It would also mean your corresponding sides are proportional. So in this first triangle, JK would be proportional to XY, KL proportional to YZ, and then ZX proportional to LJ. We can also say that these third angles are congruent by that third angle theorem that we learned in the first semester. So if we look at a couple examples here, not super tough stuff here, just kind of putting together what we were still working on in the first or before Christmas break. So example one here, I will go through A with you, and then I'll have you pause the video and work through B and C. But if we look at example A here, we have our two triangles, ABC, and then FED. First thing we got to do is figure out which angles are corresponding. Easiest way to do this, start with your right angles. So angle B has to correspond with angle E. If we take this triangle here and rotate it so that it is facing the same direction as FED, it would look like this, giving us angle B up top. A would shift to the far side, C would rotate to the bottom here, and then we have, it's easy to identify our corresponding sides. So down here we have angle C is 68 degrees. That corresponds with F. So to figure out F, we know the three angles in a triangle add up to 180. So we can take 90 plus 22 to give us 112. If we subtract those, or subtract 112 from 180, that'll give us 68 degrees for angle F. Angle F corresponds to angle C, which is also 68 degrees. So since we know all three angles are congruent here, we can say that triangle ABC is indeed similar to triangle. Now make sure your order is correct here. A corresponds with D, so we would have D. B corresponds with E, so we'd have D, E, F. And that's how we would do part A. So why don't you go ahead and pause this now and run through B and C. And when you're finished, go ahead and hit the play button again, and I'll walk through quickly what your triangle similarity would be for B and C. So in problem B here, corresponding sides here, rotate PRQ so it faces the same way as FGH. So Q would now come to the top. If Q comes to the top, P would go to this right side, R would go to this left side over here. So we have PQR just rotated. P is still 71 degrees. R is still 78 degrees. So R corresponds with F, which would line up. H would line up with P. So if we use our triangle sum theorem here, 78 plus 31 is 109. 109 or 180 minus 109 would give us 71 degrees for H, which would be congruent with P. Same thing, triangle sum theorem here would leave Q at 31 degrees, so we know that these are congruent angles, meaning triangle, let's go PQR would be similar to triangle HGF. And for C here, once again, let's make sure we can find our corresponding angles. So G would have to correspond with Q here, so let's make sure G and Q are the same measure. 53 plus 27 gives me 80. So if this is 80, that would mean Q has to be 100. 100 does not equal 110. So these angles cannot be all congruent. So these triangles in C are actually not similar. So hopefully you got those correct. Let's keep on scrolling here and take a look at example 2. So just different setup here, different starting information. We're trying to figure out if the two triangles are similar, RTV and RQS. And then in part B, we'll work on a couple different triangles. So if we take our two triangles here, if we have overlapping triangles like this, it may be easier for you to redraw them. So if I redraw TRV, okay, I know T is 49 degrees. We're not sure about R or V. Then I have QRS. Here, and Q is also 49 degrees. Can we determine if these two triangles are similar? Now, we know Q is congruent to T. We also know R is the same, so by the reflexive property, we can say R is congruent to R. If we know two angles in a triangle are congruent, we also know by third angle theorem, these must be congruent as well. Or we can just use the theorem that we learned earlier, which is the angle-angle similarity postulate. If we know two angles are congruent, we know these triangles are similar. So we can say that triangle TRV is similar to triangle QRS. Now, just like before, why don't you go ahead and pause the video, take a look at examples B and C, and then go ahead and resume the video when you are done to see if you got the correct answers. So, if we look at example B here, we are trying to say that LMN is congruent to NOP, so they're already facing the right direction. We know or are given that angle L is congruent to angle N. So to use angle-angle similarity postulate, we have to prove that there is one other angle that is congruent. So the giveaway here is we have parallel lines. So since we have parallel lines, we have OP is parallel to MN. So we can use our alternate interior angles here. Which would say that this angle here is congruent to this angle here. Unfortunately, that doesn't help us to prove that the triangles are similar yet. But what I can do is, I know that the sum of the three angles in a triangle is 180. I also know that a straight line or a straight angle is also 180. So if I know that these three angles in this triangle are equal to 180, then P here must be congruent to N here, because I have the same measured angles that have to equal 180. So by this, now I can say that N and L are congruent, or ONP is congruent to NLM, and then I can also say LNM is congruent to NPO. So I can say that triangle LN or LMN is similar to triangle NOP. And then last one here, we are going to use vertical angles. So we have the right angles here. Then I have my vertical angles here, which would give us two congruent angles. So I can say that triangle DCB is similar to triangle DFE by angle postulate. All right, so last example here. Example 3. Why don't you guys pause the video here and work through this and see if you can get it, and then go ahead and hit resume, and I will walk through it with you to make sure you guys are on the right track. So here, if we look at example 3, a lifeguard is standing beside the lifeguard chair on a beach. The lifeguard is 6 feet 4 inches tall and casts a shadow that is 48 inches long. The chair casts a shadow that is 6 feet long. How tall is the chair? Step 1, the lifeguard and the chair form two sides of a right triangle with the ground as shown. The sun's rays hit the lifeguard and the chair at the same angle. You do have two pairs of congruent angles here. So the triangles are similar by the angle-angle similarity postulate. So knowing that the two triangles are similar by the angle-angle similarity postulate, step 2 here, you can use a proportion to find the height x. We can write 6 feet 4 inches, convert that to inches. So 6 times 12 would give you 72, plus the 4 is a total of 76 inches. So you can form two ratios of feet to inches. So if we know this is really 76 inches, we know 6 feet here is really, multiply that by 12, this is 72 inches. We can say that the height here of, we'll just call it x, the height of the lifeguard stand is, remember here, we have to create ratios. So 76 over x is equal to 48 over 72. Now, here you can use your cross products. So x times 48 is 48x. That's equal to 76 times 72, which is 5,472. Then when I divide by 48, I get x is equal to 114 inches. So if you wanted to convert that to feet, you could by dividing by 12, and it would give you about 9 feet 6 inches. Either one is acceptable. It didn't specify at the top whether it wanted it in inches or feet, so either one of those I would accept. Alrighty guys, this is the first video. Hopefully I'm going to try and keep them to 15 minutes like this one was. You will have a homework assignment on Mudge, and I will go ahead and post the answer keys to the homework assignments on Mudge as well, so you'll have an opportunity to kind of check your work as you work through them. Submit them like you normally would on Mudge. PDF, make sure you get those in for me before your class starts tomorrow. Have a good day, fellas. I will see you again or post another video for you on Wednesday.